All right, let's look at section 6.4 here. We're going to be looking at graphs of quadratics and how they shift or move. So when we're talking about shifting functions, we're talking about a move from one place to another. And this is also called a translation. Now, where is this word translation from? I'm hoping you remember that last year in Math 1, right before COVID hit, we were learning about the 3 transformations from Math 1. The 3 transformations were rotation, reflection, and translation, the one that we're going to be talking about now. Translation, I think, is the simplest one because it's just moving or shifting up or down or right or left. So we're now going to be talking about, instead of lines like last year, we're going to be talking about quadratic or U-shaped graphs and how they shift. So let's talk about the movements that we're going to see. Shifting a function is moving a function. And the graph's location changes, but not its size or shape. A function can shift vertically or horizontally. Remember that horizontally means right or left, and vertically means up or down. Okay, so a shift up would be moving along the y-axis. It's when you add a number to the entire function, like this +1 back here. A movement down along the y-axis would be when you subtract a number to the entire function, like this -1 back here would be a shift down 1. A left movement is when you're moving left along the x-axis. It's when you're adding a number or a +1 inside the parentheses to the x. And moving right along the x-axis is when we are subtracting, or an x -1 in the parentheses. Let's just look at some graphs now. If this original function started down here at the origin, where would we say that it shifted? And we would say that it shifted up 3 units. 1, 2, 3. How about this one right here, starting at the origin, looking at where it shifted, it went down 3 units. One, two, three. Looking at this one right here, we would say that it shifted left 1, 2, 3 from the origin. And then likewise, we could say that this one shifted right 3 units. So each graph below shows the function f of x equals x squared shifted. Use the graph and its description to write the equation. So shifting down 1 unit and to the right 2 units. So from the origin, this shifted down 1 and right 2. So we're going to take this shift down 1 unit, and that means that we put a -1 at the end. And then the right 2 units means there's going to be an x minus 2 squared in the equation. So ax minus h squared plus k, this is our vertex form of a parabola. We're going to say if it shifted to the right 2, we're going to say x minus 2 squared, and it shifted down 1, so we're going to do a -1 at the end. Shifted up 3 units and to the left 1 unit, so up 3 is going to be a +3 at the very end of the function, and to the left 1 is going to have an x plus 1 inside the parentheses with the x. So again, x minus h squared plus k, this is our vertex form of the parabola. We're going to go x plus 1, that's the shift left, and then up 3 is going to be the +3 at the end. This means up 3, and this means left 1 unit. Okay, let's go practice some practice problems now on the checkup. All right, so the graphs below have the same shape. Write the equation of g of x. So we're taking the original function or parent function of f of x equals x squared, and you're shifting it up 3. So you take the original function, and we shifted it up 3. There's our new function g of x. Now the original function is the red one, also starting at the origin, and g of x this time has been shifted down 2, 1, 2. So we go g of x equals the original function of x squared down 2. This one has now been shifted left. It's shifted 1, 2, 3, 4 left. So this time we're going to say that g of x equals x plus 4 squared. Notice it did not shift up or down, so we could write plus 0, but we don't need to. And why is it x plus 4 again? Remember that a plus 4 in the equation is a shift 4 left on the graph. An x plus 4 means left 4. And over here we start at the origin and then we shifted right 1. So this one's going to be g of x equals x minus 1 squared for a right 1 shift. All right. Now we're going right or left and up or down. So the new vertex, left 2 and up 1, 2, 3. The new vertex is negative 2, 3. So going into this full x minus h squared plus k, my h is negative 2 and my k is 3. And so the final equation here would be x plus 2 squared plus 3. So remember that a shift left 2 shows up as plus 2 in the equation, and a shift up 3 shows up as a plus 3 at the end. Over here, we have the original parent graph of x squared, and this is shifted right 1, 2, 3, 4, and down 1. So 4, negative 1 is our new vertex. So we go x. So a right 4 shows up as x minus 4 squared in the equation, and then a down 1 shows up as a down 1 at the end. If g of x equals this, we're shifted 2 units to the left. What would be the new equation h of x? So this one I'm going to turn into factored form, the x minus 1 squared factors for the x squared minus 2x plus 1. And then if it was shifted 2 more units to the left, picture this graph is currently at right 1. And so we want it to now shift 1, 2 to the left to negative 1. And that becomes x plus 1 squared. If this function were shifted 5 units to the right and 2 units down, what would be the new equation? Sorry, I just realized I forgot to put an h here for this one. So this time, the x is going to be shifted 5 units to the right and 2 units down, so plus 8 minus 2 at the end. Final answer is 3x minus 5 squared plus 6. Suppose that this f of x minus 2, compare the graph of g of x with the graph of f of x. The graph of f of x is shifted 2 units to the right. Suppose that f of x plus 7 minus 3, compare the graph of g of x with the graph of f of x. It's shifted 7 units to the left from this right here and 3 units down from this right here. And that's it.